Welcome. We're going to be graphing absolute value functions today. So this is Unit 4, Day 4. When we graph an absolute value function, it is shaped like a V. Now, the absolute value function that's shaped like a V can be shifted up, down, left, or right, or it can be stretched, or it can be compressed, or reflected. To graph an absolute value function, we just need to know a special point called the vertex and the slope of one of the branches of the absolute value function. So the parent function is f of x is equal to the absolute value of x. This is the absolute value function. Again, it looks like a V-shaped graph. The point in the center here is called the vertex, and it's centered at the origin 0, 0. But if I use the transform function, which is located right here, it's the f of x is equal to a times the absolute value of x minus h plus k, where h moves left or right, k moves up or down, and the point h comma k is the vertex of the absolute value function, or the vertex of the V-shaped graph. And A is the slope of the right branch of the V. And when you're graphing the slope, it's basically the same thing as you're graphing a linear function. Now, before we graph absolute value functions, we need to practice identifying the vertex. So number one, we have f of x is equal to the absolute value of x minus 4. But remember, the transform function is f of x is equal to a times the absolute value of x minus h plus k, where h and k is the vertex. So if I look back at number one, again we have f of x is equal to the absolute value of x minus 4. All I need to do is compare what I have right now to the transform function. So let's go ahead and rewrite this as f of x equals, now we don't see an a value in front of the absolute value expression, but we can assume that there is an invisible one right here. So I'll write 1 times the absolute value of x minus 4. And then since there's nothing after the absolute value expression, we can assume that we're adding 0. Look, I have my x minus h plus k. And again, I'm just comparing this function to the transform function and rewriting it so it looks very, very similar. All right? So our vertex, this is h, and this is k, because it's the absolute value of x minus h plus k. So the vertex is 4, 0. So if I were to draw a sketch of the graph, the vertex should be at 4, 0. Number 2, we have g of x is equal to the absolute value of x plus 5. Again, we're going to compare this function to the transform function, and we're going to rewrite this a little bit so it looks very similar. So g of x is equal to, there's nothing from the absolute value expression, so we assume that a is 1 times the absolute value of x, and then inside the absolute value bars is just an x. But over here, it's x minus h. So what can I do to make this look like this? Well, since it's just x, you can just assume that there's an x minus 0 inside of the bars. And then we can write plus 5. So plus 5 plus k. So here is our h, and here is our k. So remember, the vertex is h comma k, so it's 0, 5. Number 3, h of x is equal to the absolute value of x plus 2 plus 3. So I'll rewrite this as h of x equals 1. There's an invisible 1 from the absolute value expression, times the absolute value of x. And look, we have x plus 2, right? But over here, it's x minus h. So how do I make this into this? Well, first of all, let's write x minus, and then I'm going to write negative 2. Because if we remember, a negative times a negative is a positive. All I'm doing right now is manipulating this expression so it looks like this, at x minus h. So all I did was took this x plus 2 and rewrote that as x minus negative 2. Again, that negative times a negative is a positive. And then let's figure out our plus k. We have plus 3, so I don't really need to change anything there. So our h and k is negative 2 comma 3. Number 4, we have j of x is equal to negative 1 over 2 times the absolute value of x minus 6 minus 2. All right, so we have j of x equals negative 1/2, which is our a, times the absolute value of x minus 6. I don't need to change anything there. And then look, we have plus k, but there's a minus 2. So it's essentially plus times negative 2. And if you remember, a positive times a negative is a negative, right? And all I'm doing right now is I'm taking that minus 2 and turning that into a plus times a negative 2. All right, so here we go. This is our h, and this is our k. So it's not negative 6 comma negative 2. It's 6 comma negative 2. Now that we know how to identify the vertex, we can go ahead and graph absolute value functions. We need to identify the vertex and the slope to make the right side of the absolute value function. So the vertex, remember, is in the form h comma k, and we look at this transform function. And the slope is the a value of our transform function, which is right in front of the absolute value expression. All right, so here we go. We're going to look at number 5. We have f of x is equal to the absolute value of x minus 5. And I can rewrite that as f of x equals 1 times the absolute value of x minus 0 plus negative 5. And our h and k is 0 comma negative 5. And the slope of the right branch is our a value, which is 1. Which I can rewrite this 1 as 1 over 1. So I can go up 1, right 1 of the right branch of this absolute value function. So here we go. Let's graph 0 comma negative 5, which is located right here. And I'm going to go up 1 over 1. It's the same process as you're graphing a linear function. So I go up 1 over 1, up 1 over 1, and there you go. That's the right side of the V. Now I'm going to go back to the vertex and basically mirror the right side. So instead of saying up 1, right 1, this time it's up 1, left 1. So I go up 1, left 1, up 1, left 1, and then you repeat the process. So up 1, left 1, and there you go. You have your V-shaped graph. So I can connect the dots. Let me fix this a little bit. There you go. All right, so that's number 5. Let's move on to number 6. We have g of x is equal to the absolute value of x plus 1 plus 4. I'll rewrite that as g of x equals 1 times the absolute value of x minus -1 plus 4. So the vertex is -1, comma 4. So this is h, that's k. And our slope is 1. So if I have 1, I'll rewrite that as 1 over 1, meaning that I go up 1, right 1 for the slope of the right branch of this absolute value function. All right, so the vertex is -1, comma 4, located right here. And I just go up 1, right 1, up 1, right 1, and then you repeat. And then for the other side of the V-shaped graph, you're going to go up 1, left 1. And there you go. Here's our V-shaped graph. I'm going to connect the dots. And that's number 6. Number 7, h of x is equal to 2 times the absolute value of x minus 4. I'll rewrite that as h of x equals 2 times the absolute value of x minus 4 plus 0. So here's our h, here's our k. 4 comma 0 is the vertex. And our slope is 2, which I'll rewrite as 2 over 1. Which means we're going to go up to right 1. So starting at the vertex, it's 4 comma 0. And we go up to right 1, up to right 1. And there you go. That's the right side of the V. Now going back to the vertex, we need to do the left side. So it's essentially up to left 1. Up to left 1, up to left 1. And that is our V-shaped graph. All right, so that's number 7. Last problem for today. F of x is equal to -2 over 3 times the absolute value of x plus 1 minus 3. I'll rewrite this as f of x equals -2 over 3. And I see x plus 1, but I want x minus -1. And I see minus 3, I want plus -3. All right, so our vertex is -1, comma -3. It's in the form h comma k. And the slope is -2/3. So I'm going down to right 3 because we have a negative slope. And if we have a negative slope, we're going down. All right, so we're starting at -1, comma -3, which is located right here. And then I'm going to go down to right 3. So down to right 3, down to right 3. And there we go. That's the right side of the V-shaped graph. And then we're going to go back to the vertex, and we're going to mirror that. So it's going to be down to left 3. So down to left 3, down to left 3, down to left 3. And that is our V-shaped graph. So I'll go ahead and connect the dots.